So since we have seen about general sliding window protocol concept in the previous videos, which is actually a theoretical concept, remember, right? This is not a protocol. This is just an idea wherein we are using a window that is sliding over these windows. The concept of sequence number, this is just a theoretical concept. Of course, the mathematics that we studied there is still valid, right? All the mathematical equations that we derived and we studied are all fully valid. But what is important here is there a protocol? Is there a proper protocol which is based on the concept of sliding window? So one such protocol is called go back N. We'll understand why it's called go back N in a little while. But let's understand how the whole protocol itself works, right? So again, let's go step by step here. I have a sender here. Let's assume my sequence number in a frame consists of 2 bits, which means my window size. Remember, my window size can be at most, it has to be less than equal to 2 power 2. Has to be less than equal to 2 power 2, right? We have seen this in the previous video. That my window size, remember, so my window size is less than equal to 2 power m, is less than equal to the minimum of 2 power m and the capacity in packages, capacity in frames or packets, right? So my window size is less than equal to 2 power 2 because my number of bits is this. So let's take a simple case with window size equals to 3 as an example, right? And of course, we send cumulative acknowledgements just like in our standard concept of sliding window. Now let's go one by one. So what do I have? I have my window size is 3. Look at this. My window size is 3, which means there are 3 frames here, right? And since I have 2 bits, I can have 4 sequence numbers. 0, 1, 2, 3, 0, 1, 2, 3, so on and so forth. I'll use this as a running example because it's easier. Okay, I have my sender, I have my receiver. Cool. So in this frame, there is a small terminology. This is called the first frame. Look at this. This is called the first frame at the sender. This is called the last frame. Often we use these symbols SF and SL to represent this. This is the first frame at the sender in the sender window. This is the last frame in the sender video. This is the current frame that it is sending. So it is sending frame 0. On the receiver end, this is very important. On the sender end, my window is of size 3. This width is 3 frames. In my go back N protocol, on the receiver end, there is also a receiver window. I haven't talked about it in the previous videos. I haven't talked about it here, right? When I talked to you about sliding window protocol, because it was a general idea that I was discussing. Now let's go into the specific practical ones. Go back N is a practical real world protocol. So what it does is there is also a window on the receiver side. Just like the way there is a window on the server side, on the sender side, not the server side, sender side, there is also a window on the receiver side. On the receiver side window, this window width is always 1 in go back N. So in go back N, the width of the receiver window is always 1. This is very, very important. So the receiver is now waiting for frame 0. Now what happens? The sender, look at this, the sender, this is the window of the sender. It will try to send everything that is in the window before it gets an acknowledgement. It can send anything that is in the window. It can't send anything that is outside the window or after the window. Everything before the window, it has already sent, right? It has also got acknowledgement for them. So it sends S. My S is now pointing to 0. So it will send frame 0. Now as soon as this receives frame 0, look at this. See, it is waiting for frame 0. My receiver is waiting because in my receiver window, which is only of width 1 in go back N protocol, it is waiting for frame 0. It got frame 0. It need not send an acknowledgement. It will wait. But what it does internally is it says, okay, I've gotten frame 0. Everything is cool. Now let me move my window. It slides its window to the next one. Now it is waiting for frame 1. Now it has sent SC, so this S was pointing to 0, it sent frame 0, then S will point to 1. Then S will point to 1. At this point, S will point to 1. Then it will send frame 1. It also sends frame 1. Receiver also received frame 1. Very good. Then the receiver now moves his window, because it's a sliding window protocol, right? The receiver now moves his window to frame number 2. And it decides to send an acknowledgement. When it sends an acknowledgement, what acknowledgement will it send? It will send acknowledgement 2 because it has already received window 0, it has already received frame 0 and frame 1 successfully, and it is waiting for frame 2. So it will send acknowledgement 2. As soon as the sender receives acknowledgement to, what does it do? Look at this. As soon as it receives acknowledgement to, this is very important. As soon as it receives acknowledgement to, what it does is it slides its window. The moment it receives A2, what does it mean? It means your frame 0 and frame 1 in my current window have been successfully transferred to the receiver, which means now I can move my sliding window. So I move my sliding window and my S now points to 2. So I send frame 2 now. Look at this. Now I send frame 2. My receiver can choose to send the acknowledgement anytime it wants. So let's assume as soon as it receives frame 2, look at this. It was waiting for frame 2. It got frame 2. Cool. Now it got frame 2. So it will slide its own window to point to frame 3. And it says, now it sends an acknowledgement with A3 saying that I have received up to 2. Now send me 3 please. Okay. This acknowledgement reaches here. Look at this. This acknowledgement reaches here. As soon as this acknowledgement reaches, what does it do? It understands that frame 2 that I have sent has successfully reached. So it will again slide the window. Look at this. It's again slided the window. It moved from this window to this window. That's what is this. Right? Now it sends 3 and so on and so forth. Right? The core idea, again, it is based on the concept of sliding window. But there is one sliding window at the sender. There is one sliding window at the receiver. The receiver window width is always equal to 1. The sender width is less than equal to 2 square. Actually, technically, we'll show this later. If I have m bits, my sender width has to be less than equal to 2 power m minus 1. So my sender window cannot be equal to 2 power m. We'll show this later. Okay, when we use go back n protocol, please understand that when we use go back n protocol, even though I wrote this, why did I write this? Why did I write this? Because we derived this in the previous video. Ws is less than equal to 1 plus 2a. Similarly, Ws is less than equal to 2m. Right? We wrote that. That's why I wrote this. But technically, it cannot be equal to 2 power m. There is a problem if it is equal to 2 power m. That we'll study little later. Right? The window size of go back n on the sender side should be less than equal to 2 power m minus 1. That's why I chose 3 here and not 4. We'll see why in a little while. Okay, just be patient. So what happens if I have a lost frame? Now let's see. Again, we have to look at all these cases, right? What happens if you have a lost frame? Let's see. Let's see how the whole thing works. So imagine same thing. So this is my sender window. This is my receiver window. It sends 0. I received 0. Then it sends 1. Cool. It has sent 0. It has sent 1. Sends 1. I send it an acknowledgement. Cool. As soon as I get an acknowledgement 2, I slide my window. Till here, everything is good. Now let's see what happens. Now I send, let's say, frame 2. Now I send frame 2. When I send frame 2, let's say frame 2 is lost. Okay, frame 2 is lost. So it sends frame 2. Then without waiting for any acknowledgement, because it doesn't know whether frame 2 reached or it got corrupted or it got lost, it sends frame 3 immediately. Remember, it sends frame 3. But on the receiver end, the receiver is waiting for frame 2. It hasn't received frame 2 because it got lost in between or it got corrupted. When this sends frame 3, it says, I will discard it. Because I'm waiting for frame 2, you're sending me frame 3. That's useless for me. After a while, just like in your stop and wait, there is also a timer here. The timer, because it is waiting for an acknowledgement for 2 or 3. It is waiting for an acknowledgement for either 2 or 3 because it has already sent 2 or 3. If it gets an acknowledgement for 2 or acknowledgement for 3, that's cool. But as soon as I send a packet or as soon as I send a frame, I'll wait for it. I'll start a timer. I have a timeout. Look at this. Remember what all I have sent? I have already sent 2. I have already sent 3. But 2 got lost. 3 was discarded here. 3 was not taken into consideration. 3 was completely discarded because this is waiting for 2 still. And because my sender did not get any acknowledgement back, it will time out after a while. When it times out, remember when it times out, what it does is it goes back to the starting frame and it resends everything. It goes back and starts resending. That's why it's called go back n. Here n basically means you might have to go back to n. So n is typically the width of the window. N is often and the variable n is often used to represent the width of the sliding window on the server side, on the sender side. On the sender side, again, I keep getting confused with this word server and sender because I have written client server programming, etc. So the sender word doesn't come to my mind. Server word comes very often. Anyway, so the variable n is often used to represent the width of the sender window. So now imagine it could have so happened that it has sent 2, it has transmitted 3, it could have transmitted 0 also, but 2 got lost. Because 2 got lost, what happens? I'm going to resend everything. I might have to resend everything that is there in this window. Now it resends 2 because we got timed out. When it sends 2, okay, this was waiting for 2 and it got 2, cool. Then it will wait for 3. Let's say it sent 2, then it sends 3. Because it can send everything that is there in the current window. It sends 3. After it sends 3, let's assume 3 is also received successfully here. Then the receiver window moves to 0. And the receiver window will say acknowledgement 0. When it says acknowledgement 0, what does that mean? I have received frame 2 and frame 3 that you sent successfully. I got an acknowledgement now. Because I got an acknowledgement, I'll move this sliding window to this 0, 1, 2 and so on and so forth. Right? So whenever there is a data frame that is lost, this will keep discarding. My receiver will keep discarding any other frames that apart from what it is expecting. Right? So this will time out, my sender will time out, and it might have to send all the frames in the current window which is of length n or width n. Right? So that's why it's called go back n, because you're going back and sending all the n frames in the window. That's why the name go back n. Right? I hope you got the context now. Now what happens? There are other cases also. I could have a delayed, lost or damaged acknowledgement. Then what happens? Imagine, just like the way a data frame could be lost, my acknowledgement also could be lost, or my acknowledgement is damaged, or my acknowledgement is delayed. Then what happens? There are broadly 2 cases that can happen. Okay? Broadly 2 cases. Again, without going into these diagrams in lots of depth, broadly 2 cases can happen. Case 1 is the acknowledgement arrives, it is delayed. Remember, it is delayed, but it arrives before timeout. Let's assume it arrives before timeout. For example, if I get an acknowledgement before timeout, then what happens? There is no need to resend any frames because we have accumulative acknowledgement. Let's assume I have sent frame 0, I have sent frame 1, I have sent frame 2. Right? Let's assume the acknowledgement from this side. Got delayed. Okay, the acknowledgement from this side got delayed and we reached here. But the timer hasn't timed out. Let's assume this is the timeout. This is the sender, this is the receiver. We haven't yet timed out. Because we haven't timed out, and so I should time out for 0. I'm sorry. So this is 0. Let's assume 0 hasn't timed out. Okay. So I sent 0. I didn't get an acknowledgement. I sent 1. Now I sent an acknowledgement which got delayed. Let's assume this acknowledgement received here. This acknowledgement was received by the sender here. Right? But this acknowledgement is an accumulative acknowledgement. So this acknowledgement will say A2. This acknowledgement will say A2. So what does that mean? This acknowledgement got delayed and it says A2, which means I received frame 0 and frame 1 successfully. So if the acknowledgement arrives before timeout, then there is no need to resend frames because we have accumulative acknowledgements. The second possibility is the acknowledgement arrives after timeout. If the acknowledgement arrives after timeout, what happens? As soon as timeout occurs, we will start resending the frames. That's what we have done here, right? See, I'm waiting for acknowledgement for 2. If I get acknowledgement for 3 also, that's okay because it's accumulative acknowledgement. But if it timeouts for 2, if I did not get an acknowledgement, if it timeouts, what happens then? I'll resend all the frames. I'll simply resend all the frames. In go back n, very importantly, this is a very important thing to note. The receiver does not resend acknowledgements. This is very, very important. The receiver never resends acknowledgements in go back n protocol. Again, this is a simple rule that people who designed go back n thought of. Right? Makes logical sense. There is no point in resending it. Let it resend the packets if it has to. That's why it's called go back n in the first place, right? Very simple concept. Now let's take a very interesting case. Again, I've taken this diagram. It's a very, 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 very nicely drawn diagram. I've taken it from CSU, Ohio, from Professor Sachinta's website, from her lecture notes. So I've also placed the source here. Very brilliantly drawn diagram. It's a very interesting case. So I told you a while ago, I told you that in the case of go back n, even though my WS, remember my WS can be less than equal to 2 power m. which means my ws can also be 2 power m, but we never use ws equals to 2 power m. We never use this. The largest value of ws in the case of go back n, in the case of go back n, this should always be less than equal to 2 power m minus 1. So this is what I told you a while ago, and I told you I'll justify it a little later. So let me take a simple example to justify it. Imagine if I have 2 bits, then what is 2 power m? 4. What is 2 power m minus 1? 3. Now let's take a simple case. Imagine. So here I have 4. Here I have my window width. Remember, my window width, my sender window width is, let's say, 4 in this case. Right? In this case, my sender window width is 3. Right? So I want to prove to you that the sender window width in go back n, this is only with respect to go back n. With respect to go back n has to be less than equal to 2 power m minus 1, and it can't be equal to 2 power m. So here we are taking 2 power m. So this is equal to 2 power m, and this is equal to 2 power m minus 1. Now let's see what happens if you have 2 power. So let's look at what happens if you have window size as 3, window size as 4. I'll show you that if you have window size 4, things can go crazily wrong. Okay, let's go step by step. If window size equals to 3, let's assume suppose this is my window, right? This is my window. I send frame 0, I start my timer. Frame 0, acknowledgement got lost. Acknowledgement got lost, right? The frame reached here. That's why the receiver window moved to 1. The frame was received here, but the acknowledgement was lost. Acknowledgement is lost. Then it sends frame 1. It keeps sending, right? Because it can send everything that's in the sender window. It sends 1, acknowledgement is lost. Worst case I'm talking about. It sends 2, great. The acknowledgement is lost. Right? But remember what's happening. Since we have successfully received it, my window kept moving from 0 to 1 to 2. Remember, my window moved here. That's very, very important. Now comes the fun thing. After 2, what happens? After 2, what happens? I get 3. Look at this. After 2, I get 3. Because I successfully received frame 2, I'll move my receiver window to 3. Now, but this, because at the sender end, I did not get acknowledgement for 0, 1 or 2. I did not get any of these acknowledgements. So when I sent my frame 0, I would start a timer. The timer will time out. When the timer times out, what happens? I will start resending 0 again. It will send frame 0, but it is expecting frame 3. And it will correctly discard this because it already received frame 0. Then it will send frame 1. It will correctly discard it. Hopefully, later on, see, this is very important. It is correctly discarding it. That is very important. Right? And then probably one of these acknowledgements will receive here and everything will work out later on. But same situation where, remember, this is a situation where all the acknowledgements are lost. All the acknowledgements are lost. In this situation, what happens if my window size equals to 4? Let's see. Okay. So I send frame 0, lost. So this moves now. I send frame 1, got it, good. I send frame 1 acknowledgement, lost. I can send frame 2. I can send everything that's in this window, right? I send frame 2, cool. It is expecting frame 2, received. It sends an acknowledgement, that is also lost. Then it sends frame 3, cool. So it has sent everything in this. It has sent everything that is there in this window. It receives frame 3, very good. Then after receiving frame 3, what does it do? It goes to the next, it slides further. Now it is waiting for frame 0. But by this time, because it hasn't received, remember the sender hasn't received any of these acknowledgements. It hasn't received acknowledgement for 0, 1, 2 or 3. It hasn't received any of these acknowledgements. So what does it do? It times out now. As soon as it times out, what happens? It will start sending this frame 0. Remember, it is sending this frame 0. Here also it's but this is expecting this frame 0. Remember, this was expecting this frame 0. But now my sender will send this frame 0. When it sends this, because it's timed out, it's resending this frame 0. But what is my receiver expecting? My receiver was expecting this frame 0. So receiver will accept it because the sequence number matches. But it is erroneously accepting it. It should not have accepted it. Right? This is the problem that you encounter if WS is equal to 2 power n, we can have a case of erroneous acceptation. You can erroneously accept it, which we don't want. This is a blunder because now everything is messed up. Remember, the sequence of frames should not be messed up. The moment you mess up the sequence of frames, the whole data is messed up. The order is messed up completely. Right? That's why WS can never be equal to 2 power m, because there is this boundary case. There is an extreme case. This is like an extreme case where every acknowledgement for every frame got lost. But as a designers of protocol, we have to think of every case that is possible. The worst of the worst case also we have to be prepared for. Hence, we never make WS equal to 2 power m. We always make it less than equal to 2 power m minus 1. Because if it is less than equal to 2 power m minus 1, everything is correctly discarded as we expected. If it is equal to 2 power m, we erroneously accept, and we don't want such a situation. Right? Phenomenal. Again, I've taken this from the lecture notes of Professor Sachinta. Brilliant diagrams. Very nice diagram. Okay, sounds good. So now let's take a simple example. So imagine I have a GBN. I have a I'm using go back N protocol with window size equals to 3. Right? My sender sends, let's say, 10 frames. Every 5th frame is lost. Then number of frames transmitted equals to. Let's see, it should be straightforward to compute it, right? Now let's see. First, what is my window? My window size is 3. So let's just number them. Let's just number these 10 frames that we have. My window size is 3. So what will I do first? I'll send window 1. I'll send 1. I'll send 2. I'll send 3. Right? Cool. So let's assume I get an acknowledgement because every 5th frame is lost. I've only sent 3 frames. Everything is cool. So I move the window. Look at this. I simply move the window now. Okay. So now my window is 4, 5, 6. Right? My window is 4, 5, 6. Okay. Let's assume 4 is also transmitted. 4 went successfully. But 5 will fail now. Remember. So let's assume. So let's take the maximum number of frames transmitted. Okay. What is the maximum number of frames that we have to transmit? Let's assume after 4 I get an acknowledgement. If I get an acknowledgement after 4, what happens? My window will move here. Look at this. This is what my window will be. I sent 4. Let's assume I got acknowledgement for 4. Cool. First 4 frames. Every 5th frame is lost. Then I send 5. I send 5 because this is in this window. Remember, this is there in this window. The question here is maximum number of frames transmitted. We have to think of the worst case. Okay. 5 is there. I send 5. Let's assume I send 6 also. I send 7 also. But I don't get any acknowledgement because the 5th frame is lost. Remember, the 5th frame is lost. This frame was lost. Because this frame was lost, let's look at the worst case. Because this, see, I don't know that this frame was lost. The sender does not know that 5th frame was lost. It will send 5, 6, 7. It will wait for acknowledgement. It doesn't get any acknowledgement. It times out. Then what does it do? It resends again. It resends 5, 6, 7. Because that's my window now. Remember, that's my window now. I'll resend 5, 6, 7. Now, when I'm resending 5, 6, 7, look at this. This is very important. When I'm resending 5, 6, 7, let's assume after 6, I get an acknowledgement. Okay, let's assume after 6, I get an acknowledgement. So, what is my window now? 7, 8, 9. This is my window now. Right? After 6, let's assume I get an acknowledgement. Cool. All that is good. But every 5th frame is corrupted. So, this is the 5th frame. So, amongst these 5 frames, this is a 5th frame got corrupted. Amongst these 5 frames, this is the 5th frame. So, it got corrupted. Now, what is my window? Again, I'm trying to go back as many as possible. That's why I'm moving these windows as much as possible. Right? Because I want to know the maximum number of frames transmitted. If my window starts at 7, I will see I send 7, I send 8, I send 9. But soon I realize that I don't see. Look at this. This is my window. 7, 8, 9 is my window. Right? My 7 did not reach. So I never got acknowledgement. Then what do? My 7 will time out. Look at this. I'm trying to send as many frames as possible here. That's why I'm making my window start at 7, 8, 9. So that I send 7, 8, 9 because my window size is 3. I can send up to these 3. 7, 8, 9 I'll send, but 7 was never received by the receiver. So what happens now? The receiver doesn't send any acknowledgement because it was lost. Which means my sender will time out at 7. Which means my sender will resend again. Let's look at this. My sender will resend 7, 8, 9 again. Right? Now, look at this. This was a problematic case. So this was sent. Now let's start counting 5 frames because every 5th frame is lost. This went successfully. This went successfully. This went successfully. Here is a problem. Even though these two were sent successfully, since I did not get acknowledgement, I resent all of them. That's the trick here. I resend everything. Right? Now what happens now? Let's assume after 8. So let's assume after 8, I got my acknowledgement. So I have 9 and 10. But since I'm in this window, I can send 10 also. I'll send 9 and 10 and I'll wait. Look, I don't have any more packets. Even though my window length can be 3, I only have 2 packets or 2 frames here, right? So I sent 9 and 10 and I'm waiting for acknowledgement. I don't get acknowledgement because 9 is again the 5th frame. 1, 2, 3, 4, 5. This 5th frame got lost. The receiver doesn't send the acknowledgement. So the waiter will time out, right? It will time out again, it will resend 9 and 10. Now we haven't reached the 5th frame. So how many frames did we send? What is the maximum number of frames that we transmit for this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Wow. So the total number of 18 frames that we have resent. The biggest problem in go back n is in a window. Look at this. Look at this case, right? 7, 8, 9. Look at this case. I sent 7, I sent 8, I sent 9. The first one did not work out. The first one was lost. The first frame was lost. So I'm forced to resend everything again, which is a huge wastage of my bandwidth. Right? Now, how do we fix it? We'll learn how to fix it using the next algorithm called the selective repeat. Okay. Now, here is an important thing. The minimum sequence number needed in stop and wait. Look at this. The sequence numbers that I have, the minimum number of sequence numbers that I need. In stop and wait, if you think about it, in stop and wait, okay, let's go back to stop and wait, right? So in stop and wait, what sequence numbers do I have? I have only 0 and 1. I have only 2 sequence numbers. I can also think of this as having window. Look at this. I can also imagine this. I can also imagine this as having one windows. I can also think of this as a windowed scheme. You can also think of stop and wait as a windowing algorithm or a sliding window algorithm, where window length at the sender and window length at the receiver, both of them are of length 1. That's what it is, right? I send 0, it is expecting 0, then I send acknowledgement, then this will move, so on and so forth, right? So one way to interpret, again, you can interpret stop and wait also as a sliding window protocol with the sender window to be of size 1 and my receiver window is also of size 1. So how many sequence numbers do I have? 0 and 1. I have only 2 sequence numbers, which means how many bits do I need? I just need 1 bit for my sequence numbers, right? Now on the other hand, in go back n, if my window size is ws, look at what we have shown. Window size is less than equal to 2 power m plus 1, right? We have shown that. So window size is less than equal to 2 power m plus 1, which means window size plus 1 is less than equal to 2 power m, right? 2 power m is the number of sequence numbers. If I have m bits, remember, if I have m bits, this is the number of sequence numbers that I have. If I have m bits, 2 power m is the number of sequence numbers that I have. Because if I have m bits, I can have 2 power m sequence numbers. So the minimum number of sequence numbers needed in GBN, right, in go back n protocol is ws plus 1, right? Ws plus 1. Look at the LHS here, ws plus 1. Now we can also interpret this as this. Look at this. What is the size of the window on the sender? Ws. What is the size of the window on the receiver? At the receiver in GBN, the window length is always 1. So this you can take it as this. This you can take it as this. So for sliding window protocols, right, the minimum number of sequence numbers that you have, the minimum number of sequence numbers needed is the size of the window on the sender side and the size of the window on the receiver side, right? Again, remember, you can also imagine stop and wait as a sliding window protocol, right? I've just discussed about this, right? Where I have my window width on the sender side is 1, my window width on the receiver side is also 1, right? Very simple concept. Again, we'll learn of one more algorithm little later, and for that also we'll see the same structure. So for sliding window protocols, again, you can interpret stop and wait as a sliding window, GBN is a sliding window, selective repeat is another algorithm that we'll learn of in the next video. For all three of them, you can, the minimum number of sequence numbers, the minimum number of sequence numbers you have is ws plus wr, which is the width of the sender window and the width of the receiver window, right? Very simple concept here.